This video is going to touch on some of the miscellaneous topics in Chapter 24. And in there, you'll see that he's got some code called generic queue, generic stack, and heaps, and just a few other files that I feel I have to talk about. And let's go over generic stack. We know what a stack is. It's the last in, first out data structure. And we've implemented a stack with an array. With the linked list, you can also use linked lists to do the job. And because the linked list has very efficient methods that apply to the extremes of the list, the front and the back, the tail end, the front end. And in this data structure, you don't really need to worry about inserting anything in the middle of a linked list. A stack is you just tack onto the end and remove from the end. So we can use a linked list to do that. Likewise, a queue is also implemented using a linked list because a queue is a first in, first out data structure. You remove from the front of the queue, remove from the head, you insert in the tail end, and you never have to go ahead and insert anything in the middle with a queue. So these linked lists is actually a very good way to implement it. In fact, there is a linked list. All the stuff that we talked about in the previous lectures here, that's all for naught. That's been developed for us already. There's a thing called linked list in the JDK because I'm just including as part of the collections series of classes in the JDK. There's a linked list that you could use. It works pretty much the same as the linked list that we had that we talked about in the my version of the series. So this is great. You don't really even need to worry about implementing anything. It's been done for us. So, okay, let's take a look at pushes and pops. Here's their push right there. This is a push method. We're going to put something into the stack. This is the linked list of strings, a linked list of whatever. Just make sure that this is a string that you put in there. E is just like a placeholder for the data type that's being manipulated by this data structure. You simply add it. What does add do? It adds it to the end of the linked list. Peeking, actually let's do pop. Pop is the better version. Popping is basically take the end of just grab the item at the end of the array, of the linked list, I'm sorry, save it, okay, remove it, remove the last element, and just return the value you popped off. Okay, how do you know if the stack is empty? Just call list.empty. I have a toString here. Grab the size of the stack to know how many elements are in the stack. You simply take this method and call list.size. And peeking is essentially popping, but you're not really removing anything from the stack. That's their version of the stack right there. Okay, take a look at the queue. The queue is missing some things. This is code that's in the textbook. Unfortunately, they're missing something like an is empty, copy. Oh, yes, I remember something. Pushing, and actually popping. You got to make sure the stack is not empty before you can pop anything. And I'm not sure why he didn't do this. If you say, before you can do all this stuff, let's go ahead and say, hey, if this stack is empty, if it's empty, okay, then return, what you're copying is an empty stack, so just return null. Return null, and we'll do that. Otherwise, if execution comes here, then you can go ahead and grab the element and remove it. I think we have to do the same thing for the peeking. Copy peek this. The peek is right there. Put that there. Okay, that works the same. Pushing, I don't believe is ever going to cause an error because you have to keep pushing for 10 minutes in a loop before you run out of memory. So that's not a worry there. Let's go to generic queue again and say, well, what's missing? I think there's an is empty that's missing. So we should probably put that in there. I think there's also a missing queue or toString. Let's go over here. There Oh, there is a two string. Okay, let's put that in there. Get rid of this two string that popped in, and say I just need a here's a D. All right, I think we're good. NQing. NQing. Well, how do you NQ something? We're putting it in the tail end. There's an add last method. DQ. Well, you can't DQ something that's empty, so we have to do the same thing we did with the stack. If let's see, this actually list, and I think I made a mistake, by the way. Not this. Oh no, that's right. That's right. I'm sorry. No, we're right. I'm right. I had a little brain burp there. This dot is empty. If it's empty, then you're not going to remove anything. You're just going to return null. And the program could check to see if you're returning null and work accordingly. Otherwise, we're going to remove the first element. And these are all big O of 1 operations because you're operating in the back of the queue, in the front of the queue, and never really worrying about the middle. So that's a good thing. Perfect methods, and we're still using the stack or the linked list that's built into the JDK right there. So let's save this, save that, and then there's a program called test stack and queue. You know what I'm going to let you do? I'm just going to let you go through this and run it. You're going to see that it functions. We make a generic stack, a generic queue, and we're putting things in there. So I'll let you do that as well. Take a look at that. Then there's a program called priority queues. Now, a priority queue is like a queue. A queue is a first in, first out, but as the name implies, it's a priority queue. What that means is things enter into the tail end of the queue always, okay? But what comes out is not necessarily the first one that's in, but the one that's got the highest priority. It's basically the classic example is an emergency room. Let me just do a source format of this, okay? Is an emergency room. And in the emergency room, a whole bunch of people enter the door of the emergency room. Some have hangnails, some have gunshot wounds. Obviously, you don't want to go first in, first out, and the guy that happens to be the gunshot wound is got to wait for the hangnails to be finished. He has to take priority. So there's a data structure that's discussed. I encourage you to look at the video, the hacker rank video that discusses heaps. It's a very important data structure. I don't think I'm going to spend too much time on the code, although the code is right here. This is the code that is in the textbook. It's also basically discussed in the video. If you're interested, you can go ahead and take a look at it. But basically what we have here is a data structure that makes sure that the highest priority element is at the very top. Okay, it doesn't really matter what all the other elements are, how they're arranged. It's just that the highest element is in the top, and the system knows when it's ready to remove something from the heap, it's guaranteed to remove the highest priority item. And then once you remove that highest priority item, it reshuffles everything in the background until the next highest value bubbles up to the top of the data structure. So basically, we're going to rely on making sure that the heap makes sure that you have the highest priority element at the very top. Now, that's a constructor that creates the heap. This is a constructor that creates a heap, but passes what's called a comparator, not comparable, but a comparator object. And a comparator is basically a way for you to determine how to order the things inside this heap. This is like the natural ordering of the elements. If this were a string, there would be an alphabetical order. But you can control how you want these elements to be positioned, what's considered less than or greater than, and the comparator will do that for you. And if you have such an object, you pass it here, and it's not going to use the natural order. It's going to use the order that's determined by this comparator that you pass it. So either way, the highest element is guaranteed to be at the top of the data structure. Okay, when you're ready to put something into it, when you want to put something into the priority queue, okay, add it. That's all you do. When you're ready to remove it, remove it. And grab its size. There you go. You have that. Now, I don't believe you have to worry about when you dequeue something. If there's nothing in the queue, I think it returns. In fact, I do know it returns null, so you don't have to put an if statement in there. So let's take a look and see if that works. I think there's a program called Test Priority Queue right here. So basically, we have some patients. We have a dummy class called patient. That patient has a name, that priority. Okay, and what we're doing is we're defining a compare to of what's considered. Like how do you compare two patients? Bottom line, the comparable interface issue has this compare to, and we see that. And all we really care about is the priority field. We don't care about the person's name. So taking a look at this, it looks like Cindy is the highest priority person in this thing. As we include these patients. These patients go into the priority queue. What comes out is going to be probably Cindy because she's got the highest priority. And yep, priority. See, Cindy, Tim, John, Jim. So in the order that they went in is not necessarily the order they come out. Okay, the priority of the patient is considered, and that's what comes out. Okay, I think we're done with chapter 24, and we'll see you in the next chapter. Bye.